Hi students, this is lesson 6.2 and today we're going to be learning about even, odd, or neither type of functions. So our agenda, we'll go over our announcements. I would like you to take the exit ticket 6.1 again. I have labeled it take 2 and it is still on those graph features. So I'd like you to try that again to make sure that you are ready for a quiz we have coming up next class. You are going to be, you're working on it right now, your Edpuzzle note 6.2. Determine if the function is even, odd, or neither. And then there are some items for extra practice that you can do. Page 14, 15, and 17, certain problems on there. Always check your work as you go with the keys posted in the classwork folder. The exit ticket, the last 10 minutes, if you could do this 6.2 to determine even, odd, or neither. And then there's a Google form to communicate your course for next year. This is not for seniors, if you could fill that out by the end of the week. And homework 6.2 is due next week. So there is the 5-point quiz this Thursday, Friday. It is on graph features. It is 5 points total, one question talking about the different features you see on the graph. So you're going to prepare by taking the exit ticket 6.1, the take 2 version. Revisit any errors or misconceptions. Then also the classwork and notes from 6.1, pages 3, 4, and 11. The keys are posted. Please make sure you're checking and revising. 6.2 homework due on March 1st and 2nd. And then office hours, please don't forget to visit at least one time during Unit 6. Okay, into the pit we go. Here is our objective. I can determine if a function is even, odd, or neither using the equation or using the graph. We're going to start looking at some graphs. This is page 6 in your packet, and please always feel free to pause the video so that you can take notes, jot down questions, and work out problems. So these graphs are all even functions. So I'm telling you right now, they are all even functions. I would like you to pause and see what you can notice. Okay, my hope is you saw some symmetry. And the line of symmetry, hopefully we're seeing that we can reflect right across the, the y-axis there. I'm doing great at putting the symmetry line down. Oh my goodness. Okay, so all of these are symmetric and we can cross right over that y-axis and we would have the exact same graph. These graphs are all odd functions. Take a moment to see if you can identify a similarity with all 6 of these graphs. Okay, these are all rotated 180 degrees. So I could get the same if I stuck a pin here and I dragged this 180 degrees. You can kind of visualize that. Okay, we're turning this here to here. You'd get the exact same picture. Now, another way to look at this is if I reflected across the y-axis and then the x-axis, you would get the same picture. So depending on how you visualize that, both of those would give you that same graph. Okay, let's go ahead and take these notes together. This is page 7 in your packet, and we're going to first define even functions. So a function is even if it is symmetric about the y-axis. Okay, so as a graph, what does this mean? Well, let's go ahead and draw one in here. So we'll just go ahead and make an absolute value graph. And if I want to reflect it, I need to have that mirror image over on the other side as well. So this is an example of a graph where the line, the y-axis, which is x equals 0, is the line of symmetry. So for a graph, this means that you can reflect a graph. Whoops. across the x-axis, sorry, the y-axis, pardon me, across the y-axis, and have an identical graph. So again, we're looking at this y-axis, and we can see that symmetry. If we reflect across the y-axis, we will produce the exact same graph. Now, as a table, what does this mean? So I'm going to give you some values to fill in here. And let's say this is -2. So as a table, what does this mean? This means the outputs that are the same distance from x equals 0. So the outputs that are the same distance from x equals 0 are identical. So if we look at this, -2 and 2 are the same distance from 0, and they are producing the exact same value. They both produce +2. And then if we look at -1 and 1, they are both the same distance from 0, and they both produce the same exact output. Okay. So for an equation, what does this mean? So for the equation, it's saying f of the opposite of x is the same as f of x. Let me try that again. Okay, notice that we see the opposite inputs. When I plug in x or the opposite of x, those two outputs are equal. So in words, we're going to say opposite inputs produce the same output. Opposite inputs, that's where we see in the highlighting here on the left, produce exactly the same output. So this is how we would see an even function. Okay, so odd function is going to be similar in structure, but obviously we're going to see something different happening in terms of the symmetry. So this is a function is odd if it is symmetric about the origin. And this is where we come into that 180 degrees that we're looking at. So this means you can rotate the graph 180 degrees and have an identical graph. You could also say, and this is what I was talking about before, that you can reflect over both axes, essentially. So we can reflect over the x-axis and then the y-axis. Again, you'll then produce the same graph. So let's take a look here. So we can say, let's say that each one of these is 2. So 2, 4, 6, 8. Okay, and this is still going to be 1 and 2. So I'm going to go here and here. And then at -1, I'm going to go down to -1. And -2, I'm going to go down to -8. All right. So let's think about what this is. If we are to go ahead and plug in 1 and -1, we get 1 and -1 actually as outputs. If I plug in 0, I get 0. If I plug in 2, I get 8. And -2, I get -8. So what's happening here? Let's take a look. When I plug in 2 and -2, I get opposite outputs. And then when I go ahead and plug in 1 and -1, again, opposite outputs. So let's go ahead and write this out. So as a table, this means the outputs that are are the same distance from x equals 0 are opposite values. Now, how are we going to write this as an equation? So this is saying that if I have f of the opposite of x, that's the same as the opposite of f of x. So in words, we're going to say opposite inputs produce opposite outputs. Okay, so we're going to be doing some algebra here. We're going to be comparing things. So we don't always graph or have a table. We're going to look at how we can prove this algebraically. Do we have an even, an odd, or neither type of a function? Here's our criteria for success. The first thing we have to do is substitute the opposite of x as the input. Then we're going to use algebraic manipulation in order to find a comparable expression. And then the last step is to show the comparison between the new and the original to determine if it's even, odd, or neither. So remember, with our even, you're going to show me that if I substitute the opposite of x, my outputs are the same. And if we're looking at odd, you're going to say that, hey, I substituted the opposite of x, and guess what that was equal to? The opposite of the original. And neither, you would tell me that both did not work. You would say for neither that, when I substitute the opposite of x, it's not the same as f of x. And it's also not the same as the opposite of f of x. Okay, so it's even, odd. You have your two statements to prove, or you would say, hey, neither of those statements are valid, and it's neither. So step one is to substitute the opposite of x. So let's go ahead and do that. So we're putting it everywhere we see an x. So this is the opposite of x to the 5th power, because it says take your input and raise it to the 5th, plus whatever your input is. That's the opposite of x. Now we want to think about a negative number, like negative 1x raised to the 5th, an odd power, is going to give me negative x to that same power, to the 5th. And then this, instead of writing plus a negative x, we're going to say minus x. Okay, we're going to think about the original, and we're going to say, those are close, but we have this negative in here. So what I'm going to do is factor the negative 1 out. And I'm going to see if this helps make my comparison. Okay, so I took a negative 1 out of each term, and I'm left with x to the 5th plus x, which is the same as f of x. So now I'm getting somewhere. So I'm going to say, hey, that's exactly what f of x is. So now we can say, f of the opposite of x is the same as the opposite of f of x. And what does that mean we have? We have an odd function, because it matches this statement right here. So this is an odd function. So that means if I were to plug in 2 and negative 2, I should get opposite outputs for those values. Okay, same thing here. Determine if we have an even, odd, or neither function. First step, substitute in the opposite of x. 1 minus, now be careful, it's the opposite of x to the 4th. Don't cancel out those two negatives. We need to do order of operations. 1 minus, what's any number to the 4th or an even power is going to be positive. So then we can say minus x to the 4th. Okay, 1 minus x to the 4th, guess what? This is exactly the same as f of x. So now we can say, hey, f of the opposite of x is the same as f of x. Therefore, we have an even function. If I plug in a number and the number that's also the same distance from 0, let's say I plugged in 2 and negative 2, I would get the exact same output. That's what that's telling us. Okay, let's go ahead and try this one. I'm going to have you try this one on your own, and then let me know even, odd, or neither. Okay, so I'm going to go ahead and do this one as well, and you can check your work. We are plugging in that negative x to both spots where the input is, in this case. Okay, so we have negative 2x minus x squared. Okay. And now, it doesn't look like the original. I am going to try to pull out a negative 1, and this is a common thing that you'll be doing just to see if we can get something here to visualize for that even, odd, or neither. Now, when I look at this, this is not equal to f of x. So we have the opposite of something. It's not f of x. This original here was also not f of x. So what I can actually say at this point is when I plugged in this value, it was not equal to the original, and it was not equal to the opposite. This is my last line here, the opposite of f of x. It's the opposite of something, but it's not f of x. So for this one, we will write neither. But you do need to show that you've looked at both scenarios to see if it could be even or odd. Okay, so this one's getting a little bit messier, but again, we're really just looking at those order of operations. So we say j of the opposite of x equals, we're going to say the cube root of the opposite of x over the opposite of x. Okay, so right when I'm looking at this, this obviously does not look like j of x, the original. So let's mess around with it. I know that inside the radical, we have a negative 1 times x. Now, you don't have to necessarily write it out the way I am, but I want to show you what that means. That's the cube root of negative 1 times the cube root of x. The cube root of negative 1, we want to say, is there a number times itself 3 times that will give us negative 1? And it's negative 1. We'd have negative 1 times negative 1 times negative 1 is negative 1. So j of the opposite of x is negative 1 times the cube root of x over negative x. Now this still does not look like the original. I do see that I can cancel. These negative 1s will cancel. A negative divided by a negative is a positive. So we are allowed to make that change, and now let's see what happens. So we have j of the opposite of x is now equal to the cube root of x over x, which, finally, this is exactly the same as j of x. So we say j of the opposite of x is equal to j of x, and now even. All right, let's try example 5 here. So we're going to go ahead again, plug in that opposite of x. Let's go ahead and try this again. Same process. The criteria is right here. We substitute, we manipulate, and then we need to show that final comparison. So the opposite of x squared plus 4 in the numerator, the opposite of x cubed minus the opposite of x. So now we have some cleaning up to do. When I square in the top, in the numerator here, that first term, we get a positive x squared plus 4. In the denominator, when I go ahead and raise this to the third power, negative x times itself 3 times, we get negative x cubed. And of course, subtracting a negative is the same as adding a positive. Okay, does not look exactly like the original. I'm going to try to factor out that negative 1. So you definitely want to play with this to see if you can get that comparison for even or odd. So I'm going to leave the numerator alone. I'm going to take a negative 1 out of the denominator. Okay, now I see that the numerator and denominator are exactly the same as h of x except for that -1. So we're getting very, very, very close. So we could think of this, if we want to look at this part here, this is the same as h of x. And what do we have? We have a -1 times the h of x. So let's go ahead and do a little more steps here. So the h of the opposite of x equals -1 times h of x. And I'm going to do a little more here. H of the opposite of x is the same as the opposite of h of x. And so now we can say that it is an odd function. If you were to graph this, and you can certainly put it into Desmos to get a feel for the graph, you should be able to see this to verify, do a sanity check for what your algebra is telling you. So I would definitely say, if you're getting a little stuck on the algebra, get a visual, and then try to come back and see where you need to go with your order of operations. Okay, so now it's time for you to do some more practice. Page 14, just spend a little bit of your time here, maybe 5-10 minutes max. Then page 15, number 2 and 3 would be good to try. There's an exit ticket, which is 6.2 for you to do by the end of class here, last 10 minutes. If you are not a senior, there is that Google form. Please fill that out by the end of this week. And then homework 6.2 is due next Monday or Tuesday. I forgot to also write the video for next class 6.3. Watch and take notes. So make sure that you go ahead and do that so that you're ready for next class when we try the next topic, which will be sign analysis.